All right, so in this video, we're going to introduce a new concept that helps us solve more quadratic equations. All right, so far, if we've been doing the quadratic formula or completing the square or anything, and we get the negative of a square root, so a square root of like -5, we would just say that there's no solution because we can't take the square root of a negative. But the no solution thing is only true if we're talking about real numbers, like numbers that you can count to, like 2, 3, 4, and so on. However, what we're going to do now is introduce complex numbers. All right, so although complex is in the name, they're not going to actually get too complicated. It's kind of one extra addition. But they allow us to expand the amount of possible solutions. And when we do this, every single quadratic will have a solution. So it's really nice because there'll never be a quadratic equation that you could possibly make that has no solution if you also use complex numbers. All right, and even though they're kind of complex and they're not real numbers, there actually are actual applications that use complex numbers. And that'll be the kind of basis for one of the projects, is kind of figuring out why are complex numbers important even though they don't actually happen in real life in the terms of numbers that you can count to. All right, so in order to create these complex numbers, all we have to do is introduce one more thing, and that's that we have to introduce an answer for the square root of -1. And what we're going to do is we're going to call that I. All right, so this lowercase I is always just going to represent the square root of -1. All right, so by just introducing this one extra thing, we'll be able to solve any quadratic. All right, so the first thing we need to do is rewrite things using this I notation. So pretty much whenever you see a negative inside of a square, it's going to have an I, and that's because this is the square root of -1 times 4. All right, the 4 we already know can come through the square root, and it's going to become a 2. All right. And before, this negative would have given us real issues, but now we know because we have this new thing I, this -1 can come through the square root, and that becomes an I. All right, generally we write the number in front of the I, so 2I is the same as the square root of -4. So just by introducing this I, we get an answer for a negative square root now. All right, and all our other things that we dealt with simplifying square roots is still going to be the same. So 27, we can pull out the -1, and then 27 is 9 times 3. So we think about the things that can and cannot pass through the square root. The things that cannot go through the square root are the 3. The 9 can go through the square root and becomes a 3. The -1 can now go through the square root, and that becomes an I. So 3I times the square root of 3 is a simplified version of that. All right, so here's one for you to try on your own. I figure out the square root of -50. And I got 5I squared root of 2. So the negative inside the square root becomes the I. 50 is 25, which becomes the 5, times 2. And again, the 2 can't come out of the square root, so it stays. All right, so 5I times the square root of 2 is the same as the square root of -50. All right, since I is just some kind of new number type thing that we're introducing, we can do a lot of operations with it. All right, for this learning objective, we're just going to look at the exponents of I. All right, so what about I squared? All right, so for now, we're just going to remember that I is the square root of -1. We want to square it. Well, we've seen a lot that a square root and a square cancel out, so that's going to give me -1. All right, so I squared is actually just -1, which is kind of surprising. I cubed. Well, something cubed is it's just multiplied by itself 3 times. And we just saw when you multiply 2 copies of I by itself, so these 2 copies are going to become -1. So this is -1 times the square root of -1, which is negative square root of -1. So I cubed, you kind of bring out 2 of the copies to be a negative sign, but you still have that one I left over, which is the square root of -1, so you could also write it as -I. And so I cubed is the same thing as just -I. I to the 4th is 4 copies of I. Well, we also saw 2 copies of I is -1. These 2 copies of I are also -1. When you multiply -1 times -1, you get +1. And so really surprisingly, if you take 4 copies of I, you just get a simple +1. And I to the 5th is 5 copies of I. But we just saw 4 copies of I. just turns into a single positive 1. So it's just positive 1 times I, and we just get I. All right, so this really kind of cyclical thing happens is that when you get enough copies of I, you just get back to kind of where you started with. So I to the 5th is the exact same thing as I to the 1st. All right, but the kind of pattern is you have I, you have negative 1, then you have negative I, then you have positive 1, and you've kind of got back to the start. Then you go I, negative 1, negative I, and 1. So it's kind of this weird pattern that happens when you start taking exponents of I. All right, so I to the 17th. All right, how could you do this without kind of thinking about it too much? Well, we know this is 17 i's. 10, 11, 12, 13, 14, 15, 16, 17. And what do you know? We know I to the 4th is equal to 1. So every single group of 4 is going to simplify really nicely. All right, so all these groups of 4 simplify really nicely. It's just a single 1. And 1 is a super easy number because it's just kind of multiplying it, doesn't change anything. And all we have is this leftover I there. So I to the 17th is actually the same as just a single I. All right, so generally what you do is take off as many copies of 4 as you can. So I would do, this is the same as I, 17 minus 4 is 13. That's the same as I to the 9th. That's the same as I to the 5th. That's the same as I to the 1st. So every single time you take off 4 copies of I, it's the same thing because there's 4 copies of I or just 1. All right, so here's one for you to try on your own. What is I raised to the 7th power? All right, so there's a couple of things to recognize. Again, you can take off 4 powers of I for free. So I to the 7th is the same as I cubed. And then I cubed is one we did in a previous example, but I cubed, you can break it down to the square and a single one. And I squared, it's pretty important to remember, it's just negative 1. All right, so I to the 7th, the kind of simplest way you could write it, it's just negative I. And generally, with the least number of exponents, the better. So I cubed and negative I are the same thing, but I would generally say this is the simpler one. So I'd prefer negative I to be your answer because that would be easier to use in other applications. All right, so go ahead and practice this. All right, the first thing about simplifying negative square roots, basically just remembering every time there's a negative square root, you're going to get an I in your final answer. And the second thing to practice is all these powers of I. All right, if I give you a power of I, what is it going to simplify to? And that kind of big thing is that I to the 4th equals 1. All right, that is the thing that will come up a lot when you're simplifying powers of I. The other being that I squared is just negative 1. All right, so you kind of start with the 4, get rid of as many 4s as you can, and if you can get rid of a 2, it just becomes a negative sign. All right, so practice these complex numbers, and we'll start using them in the next few learning objectives.